Welcome to Webinar Wednesday. We are excited for today's presentation featuring Neil Blagman of RPI. Webinar Wednesday would like to thank today's sponsor, RPI. Since 1972, RPI has reverse engineered parts to meet or exceed OEM performance requirements for hospital, medical, dental, and lab equipment. They are proud to offer quality replacement parts and excellent customer service. Visit rpiparts.com for more information. A couple of reminders before we get started. As I speak, our first of 3 HTM mixers is taking place at the Omni Interlaken Hotel in Denver, Colorado. Over 135 attendees have joined us for this event filled with networking, continuing education, and vendor engagement. Our next HTM mixer will take place October 1st and 2nd at the Hyatt Regency in Milwaukee, Wisconsin. These mixers will provide a slightly modified, less crowded, and safer environment. You can learn more by visiting htmmixer.com. We are also hosting the MD Expo in Tampa, Florida this November. We are currently accepting call for presenters. If you are interested in submitting a class for review, please visit mdexposhow.com to do so. Today's webinar is eligible for 1 CE credit from the ACI. You can obtain your CE certificate by completing the post-webinar survey. The survey will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your CE credit from the ACI, and you will be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. As I mentioned earlier, Neil Blagman is our presenter today. Neil has accumulated a wealth of knowledge that has been utilized often in his current position as product development engineer for RPI. He has developed a keen sense for troubleshooting and finding repair solutions for tabletop sterilizers. Neil, you may begin whenever you are ready.
Thank you very much. Today we're going to be talking about the Sterrad NX hydrogen peroxide sterilizer. While we're talking about the NX peroxide sterilizer, we're also going to try to relate it to the rest of the Sterrad product line, the 100NX and the 100S. This program was originally geared for the NX, and the photos in it are going to be of an NX. So this is what a NX looks like, and what we're going to be talking about today in the way of material. The peroxide process, this is what makes the NX a unique machine. It uses a solution of hydrogen peroxide to sterilize the material within the chamber. This hydrogen peroxide is delivered as a 59%. It's concentrated down to 90%. Then it's installed into the chamber with all the material, and then it's turned into a plasma. And the plasma will take the 90% hydrogen peroxide, turn it into water and free radical oxygen, which will actually do the sterilization process. Okay, so what are we talking about here? This is the actual cycle that the users will be doing. Again, we talk about how they make sure that the material is in the chamber, that it's pumped down, the aqueous solution of peroxide is put into a vaporizer, and then it's concentrated, delivered to the chamber. We take that peroxide, we apply a plasma to it, or turn it into a plasma using a current generator that's delivered onto the material, and the peroxide breaks apart, and the combination of peroxide and oxygen is what does the sterilization without leaving residue. Okay. Next slide. Next slide. Come on. Next, there it is. Okay, hydrogen peroxide concentration delivery process. So we need to be able to get the concentration of the peroxide down to a usable amount. So what we're going to do is we're going to put it into a heated chamber, and that heated chamber is going to convert the entire amount of the peroxide and any water that it carries with it into a vapor. Once we can get that vapor onto our condensing coil, we will be we'll take the hydrogen peroxide out, and then we will take the water, separate it, get rid of the water, and continue to concentrate down the hydrogen peroxide. We transfer that concentration hydrogen peroxide into the chamber. We allow it to diffuse through the instruments, getting into the various lumen and hinges of these instruments, and then we will vent it out after we have turned it into, we've reduced the hydrogen peroxide, and we have turned what remaining peroxide into water and free oxygen. Okay, and in order for the machine to function properly, we have to be able to keep track of all those processes. This is where system monitoring comes in. What we're going to be looking at, what the computer looks at, and what we have data on in our collection system. So we talk about time, how long the intervals are. Things are controlled. We only allow them to go for a certain amount of time. If a step isn't completed in a certain amount of time, the machine knows it. There are 5 temperature sensors that look at the internal temperature in various parts of the machine, since we have to very carefully control the temperature to make sure that we keep the hydrogen peroxide as a vapor and don't recondense it again. There are 2 sets of pressure transducers, one that looks at the vaporizer condenser assembly and one that looks at the chamber directly. And of course, there's a hydrogen peroxide monitor, so we can be sure that we've delivered the hydrogen peroxide to the chamber in the correct concentration, and that concentration is monitored throughout the cycle. So, breaking down the machine itself, these are pictures of an NX, and the way the machine, the NX, is organized is sort of in 3 different modules, and we're going to go over each of the modules, talk about what's contained within that module, why it's organized that way, and a little bit of troubleshooting for the various bits and pieces. So starting at the top, we have the top module. And this is now looking down at the top module, and we have one piece kind of on the side on the bottom of the page there. So I'm going to do this, turn on a pointer, and we're going to be talking about each of these individual sections. Some of them we're just going to see here. This is where the AC power is brought into the machine and distributed. There is a cooling fan. This box contains all of the CPUs and all of the various I/O cards. We have something called a vaporizer condenser assembly. That's where the hydrogen peroxide is vaporized and then concentrated before we deliver it into the chamber. We have our pressure transducers. We have a UV light, a monitoring system, a way to keep the door closed, of course, a cartridge system and a way to get the hydrogen peroxide out of the cartridge. And then down here on the side, we have our DC power supply to supply DC power to the CPU and the I/O cards. On the back of the machine itself, that's where the power cord comes in, and there's also a data card for all the runs that sticks out the back here. It's not quite shown. Okay, so we're going to break those sections down. This is the hydrogen peroxide delivery system. And basically what you have is a cartridge. There are 10 openings in the cartridge. Each run requires 2 of these slots to make up the complete hydrogen peroxide delivery. The process of putting in a cassette, there is a barcode reader that reads the barcode on the cassette. That barcode contains the out date for the cassette and information about that specific manufacturing process for that cassette. There is also one additional barcode on this tray assembly, and that's how the machine knows if the tray is filled, because the barcode reader, which is over here, and let me turn the laser pointer back on. The barcode reader over here can no longer see this barcode when the tray is full. So the machine automatically positions the cassette, and there is a needle system that punctures the cassette. There is a filter that applies filtered air to the cassette, a pump that pumps out the material in the cassette, and a valve that allows that material to flow down a piece of flare tubing from the peroxide delivery system into the vaporizer condenser assembly, which you can see over here on the right-hand side. The peroxide is delivered from the end of the vaporizer condenser. Well, that's not working right. We move the peroxide through the system and out into the chamber. Now, one thing I wanted to point out about this system is this valve right here. So if you are looking for a vacuum leak in this system, in the NX, the very furthest spot that you can find a vacuum leak is actually this valve. It's the very furthest place from the chamber. And from this valve, you need to have a solid vacuum system. So you would look, if you were looking for a leak, you can start there, go through the transfer tubing, go through the various fittings that are involved in the vaporizer condenser assembly, and you should be able to track down some leaks at that point. Okay, so what happens in the vaporizing system? Well, we take the hydrogen peroxide that we got out of the cartridge, and it comes to us as a mixture of water and hydrogen peroxide at 59%. We need to concentrate that down. So basically what happens within the vaporizer condenser is there is a tray in the bottom, approximately under here. It has an opening in it. It's heated up to a very high temperature. As soon as the peroxide comes in through that piece of tubing we talked about earlier, it's immediately vaporized along with the water it contains, leaving behind any salts or preservatives that are used in the assembly of the cartridge. That vapor is then transferred into a series of metal bars that run through the middle of this condenser assembly. And these thermoelectric modules can be controlled at very specific temperatures. And we basically condense out the hydrogen peroxide away from the water, thus concentrating it. Then we take the water and we send it away through this vaporizer condenser assembly into the chamber, out through the pumping system and into atmosphere, getting rid of it, taking the 59% hydrogen peroxide and concentrating it down to 90% before we then transfer the hydrogen peroxide through a series of valves into the chamber itself. Okay, so we're now looking at the middle module, and the middle module contains things like the actual chamber and things that interact with it. So we have, of course, the chamber. There are trays within the chamber, and there is a gasket around the chamber to make sure that we can seal it off. Put this back on the cursor again. There we go, on the laser pointer. So we have a gasket that seals the chamber. Also the door, flat surface to make sure we don't have any leaks. We have an inner chamber, which is electrically conductive, and it's connected to our RF supply using a feed through that is electrically insulated from the outer parts of the chamber. We also have a door lock that ensures that the door is closed and stays closed. We also have a door sensor. This door sensor makes sure that you cannot turn the low frequency power supply or the plasma on while the door is open under any circumstance. Also within the door frame, we have heaters to prevent the hydrogen peroxide from condensing on the inside of the door. We have a monitoring system for the hydrogen peroxide, which starts at the top of the chamber with a UV lamp that sends light through 3 separate lenses, one that's mounted here at the top of the chamber, one that's mounted here at the bottom of the chamber, and one that's mounted right above something called the hydrogen peroxide monitoring detector, which is screwed into the bottom behind the printer. One of the reasons that I'm pointing out this peroxide detector is because it's very close to the front of the machine, and if you're working anywhere within the bottom of the machine, it's very easy to hit this device. The hydrogen peroxide monitor is extremely static sensitive. You never want to unplug it while the machine is powered up. You never want to unplug it without being properly grounded, and you never ever want to unplug it without having some sort of, while the machine is plugged in or with the machine turned on. Here we have the vacuum fittings that allow the pump to depressurize the chamber by pulling a solid vacuum. And on the top part, we mentioned earlier the hydrogen peroxide lamp. Here it is again. So we're looking down at the top of the machine. And this is the pressure sensor that is used to determine the pressure within the vaporizer condenser. That should be everything on the middle module. Okay, the plasma subsystem. So once the hydrogen peroxide has been concentrated and has been released into the chamber and has been allowed to flow into the various lumen, hinges, and very fine places within the material in the chamber, we then turn on a low frequency power supply, and that low frequency power supply generates a plasma because it's flowing between this surface and the chamber wall, and that allows that plasma to develop, and that plasma will spread through the entire contents of the chamber, through all the hydrogen peroxide, getting into all of the lumen, getting into all of the hinges, getting into every spot that it needs to. The way that's done is through a power supply. There is also a feed through that allows the electricity to come into the chamber and not directly contact the chamber walls. And there is also a separate door sensor to be sure that you cannot turn this system on when the door is actually opened. The middle module also contains the hydrogen peroxide system, as we talked about earlier. The hydrogen peroxide monitor uses a UV light to measure the transmittance through whatever material is in the chamber. The UV detector is located on the bottom. The light is located at the top. The bottom module, this is where all the vacuum process comes in. We have our printer down here, which is a completely separate unit. We have our low frequency power supply, which we talked about before as part of the plasma system. We have our vacuum pump and our oil management system. Within this oil management system, we have our vacuum subsystem. we have a coalescing filter that collects any oil that may be getting into the escaping air out of the vacuum pump. And we also have a catalytic converter that will catch any hydrogen peroxide that may have slipped through the plasma process and gotten actually out with the airstream to this point. Catalytic converter contains a chemical that continues the process of breaking down the hydrogen peroxide. Vacuum subsystem evacuates the chamber, controls the chamber pressure, and allows filter air in through venting. The vent for the allowing air into the chamber is located in the top module. Okay, so this is what the peroxide process looks like. Basically what we do is we put our material into the chamber. We allow all of our surfaces to acquire the correct temperature so that we can control where the hydrogen peroxide is and where it winds up going. And then once that system is warmed up, we deliver the hydrogen peroxide to the chamber we deliver the peroxide from the chamber to the vaporizer, pump down the vaporizer, we then deliver it to the chamber. And we transfer it. Okay, sorry about that. We pump down, we warm up all of these systems to make sure they are ready to go through our first run. We transfer the hydrogen peroxide from the vaporizer to the condenser. We check to be sure that the pressure is proper. We allow it to diffuse through the various lumens and the various hinges and spots within the material that's in the chamber until we finally feel it's been transferred and delivered, and then we turn on the plasma pumps to turn it into a plasma that breaks down the hydrogen peroxide, and then we vent it out to air. This process is done twice in each run, delivering approximately 1.8 mils of 59% hydrogen peroxide concentrated down to 90% nominal. Okay, warm up. What does the warm up do? The warm up controls the heaters to achieve the desired temperature, and it allows us to clean the transfer valve. That's a step that will become important later when we move the peroxide. We deliver the hydrogen peroxide into the vaporizer at 59%. We remove the peroxide from the system. We transfer that material into the vaporizer condenser to be condensed. Chamber pressure. We need to look at the chamber to make sure that when we transfer the condensed hydrogen peroxide, the pressure in the chamber is lower than the pressure in the vaporizer condenser assembly, and that allows the peroxide to move from the higher pressure to the lower pressure, thus filling the space within the chamber and spreading out throughout all the various spots we're trying to reach. Oops, back. Why did it? Give me back. Okay. The transfer. Okay, so the transfer time. We keep the valves open for a specific period of time, and we keep the condenser heated to a correct temperature so that none of the peroxide condenses within the transfer system. We look at the hydrogen peroxide through the monitoring system. If it does not show up within 3.6 minutes in the standard cycle, that'll cause a transfer timeout, or 7 minutes within the advanced cycle. The advanced cycles are longer and allow the machine to move the materials in a better pace, more leisurely pace. Okay, pressure check. So now that we've put our peroxide into the chamber, we want to make sure that the pressure has not changed or reacted with the transfer. We keep a control over the pressure or the vacuum in torrs between 2.8 and 18 torr, and that should produce a concentration in the lumen and the various hinges of approximately 380 milligrams per standard liter of airspace, what would be within the chamber. We allow that to sit within the chamber. To diffuse in, whoops, why does it do that? We allow the material to sit in the chamber, and we allow air to flow into the chamber to let the hydrogen peroxide diffuse into the very smallest places within the instruments that are contained within the chamber. That's diffusion step spreads the hydrogen peroxide into every possible place that it needs to reach. And once it's uniformly spread, we allow the air from the chamber, we allow air into the chamber through the venting, and that air forces the diffused hydrogen peroxide into every space that is no longer under vacuum. That's what does the full diffusion through all the lumens and through all the hinges. Once the machine has diffused the peroxide and we are assured that it has reached every place possible, we then pull out any extra air and any undiffused peroxide by pulling a solid vacuum, and then we cool the condenser to make sure that there's no peroxide getting back through the system, getting it ready for the next delivery. Once we've got the plasma, once we're ready with the plasma pump down, we then turn on the plasma, which spreads through the entire material in the chamber, and that plasma must light within 45 seconds. The machine can tell when the plasma is lit, and the actual process of generating the plasma, during that process, we will also pull a much more solid vacuum, making sure that we have all of that peroxide where it can go. We want to be sure it's completely diffused. The plasma power supply delivers at 500 watts, and it will remain on for 4 minutes. Once that 4 minutes up and we feel fairly confident that we have broken the bonds within the hydrogen peroxide, so that we have released all possible free oxygen and produced all possible water, we will then vent the chamber to air and allow filtered air through a HEPA filter. And we will also double check the transition valve by opening and closing it an additional 5 times to make sure that it is not clogged and it is ready for the next cycle. The next cycle reproduces what we just saw. We do that twice per run. So in talking about hydrogen peroxide sterilizers or any well, this does apply specifically to hydrogen peroxide sterilizers. This is a list of warnings that everyone who touches this machine or has worked under the cabinet should be aware of. And one in particular that I might point out is that when you open the door of the peroxide sterilizer at the end of the run, there is still a possibility there might be some small amount of hydrogen peroxide left within the chamber. You just don't want to put your nose directly in front of the door when you open it. Just make sure that you let the air within the chamber dissipate a little bit before you pull the material out. Thank you. Okay, again, we talk about hydrogen peroxide. There is a UV system, and of course, whenever you're working on electronics, be very careful to avoid getting electrical shocks. So, diagnostics. This machine has built-in diagnostics that you can run through a service password. This is what's included within the diagnostics, all the various systems that are checked. This process takes about 13 minutes to complete, and when it's done, it will print out a printing sheet that gives you the results of all of these tests. Okay, so we're going to talk a little bit about what kind of errors we can see within the hydrogen peroxide systems. Now, this applies to both the 100NX as well as the NX. Um, there are problems that this machine can see with how long it takes to pull the vacuums necessary. Um, One of the most important reasons why a machine might not be able to pull a good enough vacuum is because moisture is within the original load. This machine is very sensitive to water. Water continues to outgas as the machine tries to pull a vacuum. If you do have any moisture within the system, it will trigger some errors. Also, one of the things that the machine looks at as an error is if the hydrogen peroxide made it through the system. And there are several places where the hydrogen peroxide might not reach the detectors. One of the most important problems is with the hydrogen peroxide detector itself. Since it's located in the front of the chamber and the load is directly below it, if the load put into the chamber was not far enough into the back of the chamber or has shifted during the process of closing the door, it's possible that some of that material might get in the way of the hydrogen peroxide detection system. So we want to be sure that there is nothing blocking the light between the UV bulb and the detector at the bottom. Pouches are notoriously bad for this. There is also a possibility that there might be debris that has gotten onto the lenses. The lenses are replaced, the two inner lenses are replaced as part of the planned maintenance, and we want to be sure that no material collects on them, has fallen on them, dust or whatever material might be within the inner chamber of this sterilizer. The next step, of course, is the possibility that we have, if the machine should trigger these errors, we want to be sure that we handle the material properly. So we talk about how we need to remove the load if there is an issue. We will probably need to check the cassette to be sure that it delivered the peroxide properly. Okay, so those are a couple of errors. There are others. We also want to be sure that this machine gets maintained properly. So there are planned maintenances that are set for this system. Excuse me. Okay, so there are normally 2 planned maintenances that are done on this machine, 6 months apart. There is a biennial kit that allows us to replace all of the material that would break down in the oil. The biennial kit is an oil kit. Um, it is an oil change done every 6 months. We also have an annual kit, it's called the PM Kit 2, that also contains the biannual kit allows you to do the oil change and includes things like the rails that are within the chamber, which will decay from the exposure to the hydrogen peroxide. We get a new catalytic converter that will break down over time. We had a new UV lamp, which we want to make sure stays working through the entire year, and a door gasket. This PM kit is for the NX, but we also have available kits for the 100 NX, including basically a oil change kit, as well as the full rails and oil change kit, including a door gasket. Within the oil change kits, we have coalescing filters to be sure that the pump doesn't spew oil into the catalytic converter or into the air. We also have both an annual and a biannual PM kit for the 100S. Now, the 100S does deliver its hydrogen peroxide very differently. It does not have a vaporizer condenser assembly. It takes the hydrogen peroxide directly at 59% and transfers it into the chamber directly at 59% and manipulates it from there. There are also rails and a catalytic converter that need to be replaced on a yearly basis. So again, what do we have included in these planned maintenance kits, and why are we checking them? Well, way back at the very beginning of the system, we talked about how the hydrogen peroxide was transferred from the cartridges into the vaporizer condenser using sterile air. And this is the sterile air filter that prevents any contamination from flowing in with the hydrogen peroxide. There are also tubes that keep the valves seated properly within the vaporizer condenser assembly, and there is a pump in there as well. Within the PM kit, we have an oil mist filter. These vacuum pumps that are used in hydrogen peroxide sterilizers will generate an oil mist along with the outflowing air. We need to condense that mist, return it back to the pump so it can use it as oil. We give you the amount of vacuum pump oil that you will need. We give a way to manipulate the oil and an empty bottle so that you can take the oil that's been used within the system successfully and treat it properly. The oil that is generated as part of this planned maintenance should be considered hazardous waste, as it will have some hydrogen peroxide mixed in with it. So we want to be sure we handled it correctly, and we have an empty bottle included within the kit so you have a place to put it. There's a catalytic converter included in these kits. Make sure when you install this that you are careful about these threads. They are just molded. They can cross thread occasionally. Take your time. You should be okay getting it in. It's not that complicated, but it is a very fine thread. Also included in the PM kit is a HEPA filter. This HEPA filter is what filters the main body of air that's allowed into the chamber when we vent the actual chamber. It does not take the air through that little disc filter I showed you earlier. This filter is located on the top of the machine as part of the venting and the pressure measurement system. We have a door O-ring seal. You want to pull the door ring out carefully. There is a plastic pick available to get it out. When you get the O-ring out, make sure you clean the door ring gasket, the door gasket ring, to make sure that there's nothing going to block the new gasket from going in. We do recommend that you lightly coat the gasket, pressing the ring into the groove in the door until it's completely seated. try to avoid stretching the door seal when installing it. Okay, chamber rails. As we said earlier, the chamber rails tend to decay over time with exposure to the peroxide. So every year we want to be sure we put new plasticware into the chamber, and they are included. There is also a UV lamp, as we talked about earlier. Please do not handle the UV lamp without wearing gloves. The oil from your skin can damage the lamp and blacken it. Make sure that you have the correct Allen wrench to remove the original lamp, it's a very small one, and that you get the new lamp in properly seated and that the line on the bulb is aligned with the line on the lamp holder. We have a set of optical windows included in the planned maintenance kits. One of them goes in the top below the UV lamp assembly. Make sure that it's seated properly and the O-ring is in properly. The second optical window, is located in the bottom of the chamber and just fits into an opening. As I mentioned earlier, there is also a third window, part of the detector optical system. If you need to get to that third window, if you want to polish it or clean it, be very careful again when removing the optical detector. It is extremely static sensitive. Make sure you do not remove that cable with the machine plugged in, and make sure that you are wearing proper static safe wrist straps to make sure that you don't damage the optical detector. There is a thermal print head. It can be cleaned. Alcohol on a swab works well. Included in the PM kit, there are 5 thermistors. 2 of them are on the vaporizer condenser. 1 of them is on the door. 2 of them on the chamber. They should all be replaced as part of the planned maintenance, and you should be using new thermal compound when you install them. There's also an air filter in the base of the machine that should be changed on a yearly basis. Okay, so one of the problems that we have heard about on these machines involves the vaporizer condenser assembly. As we have in this illustration, we've taken the vaporizer condenser and we've blown it apart. Now within this vaporizer condenser assembly, and I'm going to turn my laser pointer on here, the hydrogen peroxide comes in through this tube. It's a swaged fitting. It's delivered into this tray, and then it's vaporized to condense on the rods on the vaporizer condenser assembly. Now, one of the problems we have heard about with this assembly is in this bottom area where the fluid is vaporized, it can develop salt deposits that are a byproduct of the processing system used to manufacture the hydrogen peroxide cartridges. There's also preservatives that are used within the hydrogen peroxide cartridge. There is also an insulator separating this subassembly from this subassembly, and that insulator will break down eventually with exposure to the hydrogen peroxide. So we have a kit available that includes all of these parts that are highlighted in color. We also include a new vaporizer manifold assembly that includes an inlet valve and a transition valve, since they are the last steps that this hydrogen peroxide see before it's sent into the chamber. And you can build up salt deposits within this assembly as well, and we want you to be able to replace it without needing to clean it. So this vaporizer condenser kit is available for the NX, and there's also a version for it for the 100NX. The 100S does not do this process. It has an injector assembly, and it also has a separate kit as well. RPI wants you to be able to support these machines, so we are coming out, or we have come out with the various some test kits that will come in handy as you're working on this machine, and some tools that should come in handy when you're working on the NX 100NX or the 100S. We have a vacuum test gauge. This kit works with all three machines. There's nothing else additional needed for the 100S or the 100 or the 100S or the 100NX. We also have calibration resistors, so you can calibrate the temperature measurement system in the NX and the 100NX. In the way of tools, we have a soft draw plier that's used to open up the Ultrator fittings that are used in various spots in the machine without marring them. We have a spanner wrench to open up the vent valve, which is kind of a different size. We also have repair kits for the vent valves in case you need to repair them. We also have a spanner wrench that is used on the transition and inlet valves, which have a different size from the vent valve. And RPI also has available technical support. We have information on our website. We have one-on-one tech help from people like me. Feel free to call. We have our mobile site where all of our materials are available, as well as our full catalog, and you can get pricing. We have an e-library that contains a lot of the technical support guides and installation instructions that we have created. We have our tech talks and our service tips within there. And of course, we have PM kits, and we do a yearly poster. And thank you very much. I will be answering any questions that you guys have directly. That concludes the presentation.
Hi, Neil. Yes, thank you so much. That was a great presentation. And we did actually have a couple of questions come through that I would like to pose to you now. The first one, what are the standard cycles and what is the run length for each cycle?
So there are two cycles available. One is the standard, called the standard cycle. It runs for 28 minutes. There is also an advanced cycle for very, very fine, very delicate instruments that runs 38 minutes, and it allows the peroxide more time to vaporize and diffuse. It runs at a slightly different temperature to make sure that the peroxide gets through to every place it can, but it does add 10 minutes to the cycle time. Each of these cycles uses the same amount of peroxide, 1.8 mils of 59% hydrogen peroxide.
Great, thank you. The next question that came in, what happens if there is a cycle fault or we need to cancel a run?
There may be reasons why you would want to do that. You left something out of a run, put something into a run, you didn't intend on it, or there is an error in the machine. If an error does show up within the machine, there is a built-in shutdown process that the machine goes through. It takes about 3 minutes. It involves 2 pump downs and a plasma delivery of about 2 minutes. So once you do stop the machine, don't expect to be able to open it up immediately. It'll take between 2 and 3 minutes before the machine will be ready for you to get the stuff out. Make sure when you pull whatever is in the machine out after a stop cycle that you use proper personal protection equipment, gloves, a mask to avoid breathing any hydrogen peroxide that may linger within the chamber.
Excellent. And I think we have time for one more question. The question is, I'm having problems with the boot up process on my NX. Do you have any suggestions?
This has been a problem that I have heard several times, and I have to admit my solutions vary depending upon the situation, but I can tell you that what's going on is the machine is failing to complete the boot up process. If you don't see the software for the NX100 or the 100NX is written in Linux, and if you don't see the little Linux penguin come up on your display, your boot process has not started properly. Now, I have heard of several solutions to that. One is kind of a carryover from the old-fashioned computer days where if your original computer didn't boot properly, you could kind of hot boot it by turning the power off, turning the power back very quickly, and it allows any capacitors that are within the system to maintain voltages, and the boot tends to skip the problems that you may be running into. One of the other places that you might want to look if you're having this problem is there is a watch battery on the CPU board that tends to decay over time. If that watch battery fails, the basic boot ROM decays and the boot system won't start. So you might want to take a look at that battery. Also, there is a second memory card also on the CPU board that contains the actual operating system. If that memory card becomes damaged, or you lose the if it can't be read for any reason, you won't boot properly. So you might want to reset that memory card as part of the troubleshooting process.
Excellent. Well, thank you so much, Neil. If we weren't able to get to your question today, RPI will receive a copy of all the questions submitted, and Neil will be able to respond to those after the conclusion of the webinar. Thank you again, Neil, for your time today. That was a great presentation. I'd like to encourage everyone to visit today's sponsor to learn more about the products they provide to our industry. Visit rpiparts.com. A quick reminder, you can obtain your CE certificate by completing the post-webinar survey. The survey will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your CE credit from the ACI, and you will be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. We will be back next week with another great webinar. Visit Webinar Wednesday Live for more details and a complimentary registration. Thanks, everyone.